Hi everyone, I'm Nick Marshall, the Managing Director of Amiga Red Group, and I'd like to welcome you to our very first episode of Grounded in Safety, Anchored, Connected, Protected. A platform built to inform, educate and inspire those working within power earthing, lightning protection and height safety services, from design, installation, asset management through to repairs and everything in between. At Amiga Red Group, we firmly believe knowledge shared is safety multiplied. This podcast opens real conversations with industry experts, sharing insights, experiences and practical guidance to raise standards across our sector. Whether you're on site, in the office or simply curious, there's something here for you. Our mission is simple. It's about raising the bar, connecting people, elevating expertise and championing safety in everything that we do. Today, we're diving into the electrifying world of lightning protection, how the industry has developed, changes in standards, and ultimately why it matters. I'm happy to say today that I'm joined by Matt Waldram, Amiga Red Group's Technical and Compliance Manager for Lightning Protection. Hi, Matt.
Good morning, Nick.
Good morning, and welcome to our first podcast. For all the new viewers and listeners, depending on how they decide to consume this content, just give us a brief introduction regards who you are and how you got into the role and what drives you from a lightning protection perspective.
Okay, thank you. Thanks for inviting me. It's good to be here. I know that I'm passionate about everything we do, and in particular, all things lightning and surge protection. My working life began with an electrical apprenticeship quite a long time ago now, and generally I worked on industrial and commercial projects across the UK. And after many years of installing electrical systems, I moved into the inspection, testing and commissioning side of the industry. And that brought me into close contact with British standards documents, such as what's now known as BS 7671, and people might know that as the wiring regulations. And that is the document that basically makes sure that things of an electrical nature are done safely and correctly.
And what kind of got you into that then? Because that's quite a technical role. What kind of drove you to say that's something which really ticked your boxes?
So I really enjoyed the practical aspect of electrical installation, but I was curious about why we installed what we installed. Mm-hmm. And therefore, the regulatory side became of interest because I found it better to understand why we were doing what we were doing rather than just installing things. Mm-hmm. But having a practical installation background is extremely useful in that industry and in this, because it means that we know how things are built. Mm-hmm. And therefore, when we come to lightning and we're trying to prevent the effects of lightning affecting things like electrical equipment, then obviously we are able to design our systems, our protective systems, in the best way so that they prevent equipment from failing and they obviously keep people safe. And there are various ways that we do that.
Really interesting. And what drives you in the role then?
I just really enjoy digging deep, as other colleagues do too, and appreciating all the things that the hard work that goes into standards development, of which I'm involved, and obviously the best way to protect things and to stop damage happening.
So as part of your role of compliance and technical manager within Amiga Red, how are you working internally and externally with different awarding bodies?
Very good question, Nick. So after a few years in the lightning protection industry, I became involved in standards development, and that was via our trade and industry body known as Atlas, which is the Association of Technical Lightning and Access Specialists.
A mouthful, that one, Matt.
Absolutely, which is why people call it Atlas. Yeah. And I am the current chair of their Lightning Protection Technical Committee, and we field questions from other members of Atlas and also from members of the public and end users, and providing them with sort of technical solutions. And we push out information to our industry through Atlas for technical changes and updates to regulations. And as part of the role with Atlas, that brought me into contact with the British Standards Institution, the BSI. And so I am a member and former chair of their committee, GEL 81, which is for lightning protection. And through that membership, I also am a member of TC81, Technical Committee, for the IEC. And the IEC is the International Electrotechnical Commission, based in Geneva in Switzerland, which is a worldwide standards body. And they are the leading organisation for creating and publishing international standards for all things electrical, etc., across the world.
So when I listen to that, I know there's a real pedigree of person we've got in front of ourselves there that can talk about lightning protection in some real detail, and that vast experience helps us add value to our clients. So today, for our people that are consuming this content, just talk me through then what you see as some of the things that are happening within the market at the moment from a lightning protection. What's changing? What are the misconceptions that you see? There must be a hell of a lot that comes out there on a day-to-day basis where people are asking questions through sheer lack of understanding. So just give us a little bit of insight into those areas.
Yes, lack of understanding is common, I suppose.
Yeah.
I think it's partly our job through being part of Omega and also the wider industry to hopefully help and improve people's knowledge and improve their understanding all around the risks associated with lightning and the damage that it can do. So in the UK, we used to have what you might call pure British standards for many, many years, going back some 80 years and more. But we've moved from that mainly UK-based view into more of a worldwide outlook by the pooling of international knowledge, guidance, and implementation of best practice. And it's all about really protecting against the catastrophic effects that lightning can have.
Yeah.
And we've done that, if you like, through the development of international standards. So when we had our British standards, they were good standards, but and because they were adopted across the world by countries that maybe didn't have their own standard.
Yeah.
But then what happened a number of years ago was the international community through the IEC got together and produced a document all around protection against lightning. And that is known as IEC 62305.
Yeah.
So we adopt that in the UK, and that became our first edition back in 2006. And that document became BS EN 62305, BS for British Standard, EN for European Norm, because it was a document that was harmonised through the European committees and then adopted by all the countries across Europe.
Yeah.
So, for example, Germany would have DEEN and France would have FREN.
So what are some of the misconceptions that you come across on a daily basis through working with an Omega, but also working within the different awarding bodies and the committees? Just give our listeners some insight into some of the things that you come across.
Okay, so the biggest misconceptions are probably that clients don't fully appreciate the risks that lightning can pose, and therefore underestimate the damage that can be done or can be suffered, and therefore don't perhaps take or expect to take all of the preventative measures that they could take.
Yeah.
One of the most common misconceptions might be that lightning does not strike twice in the same place. And the reality is that if it's struck once, then it could easily strike again, and it often does. If, for example, we took a building like the Shard in London, then, it's very tall. It's over 300 meters high. It's constructed of steel reinforced concrete.
Yeah.
Those are materials that are commonly used as part of lightning protection systems. And when they're properly connected together, they're a very good conductor of electricity, which of course is what lightning is. Therefore, the Shard offers lightning a very good path by which to discharge and dissipate through into the ground. And that's really what we want it to do. If the weather conditions are favourable for lightning in central London, then taller buildings such as the Shard are probably the most likely to take a direct strike.
Okay. Any others that you come across? Because one of the misconceptions sometimes it is about the size of the building, isn't it? But actually there's buildings that are smaller that could be hit, and it goes back to managing risk and what damage that could do. What are some of the misconceptions you see there as well from a fire perspective?
So one of the processes that we have in what we do and given to us by our documents, whichever version of 62305 is being used, is the risk management process.
Yeah.
And when we risk manage or risk assess whether or not a building is likely to suffer loss because of lightning, one of the things we look at is the incidence of lightning in a certain area.
Yeah.
And lightning will strike twice in the same place, and multiple times, etc., is not uncommon.
Yeah.
But it doesn't only strike tall buildings. It will also strike the ground, and it does so regularly. In the UK, that happens about 300,000 times a year.
That's a big stat.
It is a big stat. And on average, that's about 800 times or more than 800 times per day.
Okay.
Somewhere.
And what happens when it hits the ground then? What's the possibilities that can happen from a building that surrounds it?
Okay, so if lightning hits the ground, then the energy will dissipate through the ground and into the ground, but that would be dependent upon how resistive the ground is to allowing that energy to flow.
Okay.
The harder the ground and the more resistive it is, then the wider the area that the lightning energy will travel across.
Okay.
So, for example, if you had an area like Dartmoor, which is underlying granite, then the lightning will not penetrate the ground very deeply, but it will spread across the top of the ground. If it finds metallic elements buried in the ground, then the lightning energy can induce itself into those and can travel into buildings. And if there's electrical equipment connected to the ends of those, it can blow it to pieces.
Okay.
And that's one of the damages that lightning can cause.
Yeah, so that's quite drastic, isn't it, when we talk about what destruction that lightning does. So what are some of the things that prevent that then? So you hear the things about surge devices, don't you, as well? Is that where surge device would come in through that example?
So yes, when we consider lightning and when we consider about protecting against lightning, we sort of do it in two ways.
Okay.
We have an external system and an internal system.
Yeah.
The external system is the one that people might see on the outside of a building.
Yeah.
Tape conductors and things like that. And then the internal parts is all about preventing lightning energy from entering a building. And that is mostly done through cabled services. And as I mentioned about lightning spreading across the ground, if it finds buried cables and things, the lightning energy can get into those cables. It can travel along them. And yes, you can take preventative measures to stop it causing fires.
Yeah.
And you would do that by installing surge protection devices where cables enter and exit buildings. And they will also have the effect of protecting equipment from being damaged as well or failing because of the amount of voltage that's present. And we call that a surge, basically.
Okay.
And where it overwhelms equipment.
Yeah.
So lightning can cause fires, which is the biggest risk. And obviously it can cause failure of electrical equipment because the equipment is overwhelmed by the amount of energy that's presented to it.
Okay. I think when you've gone to a client site, because I'm just thinking people listening to this podcast now will be going, what should I be looking for on my site? And when you do go onto a site and you're looking at all the different risks that they're managing, I'm guessing that some customers could be very transactional in just looking at a certain area rather than seeing that bigger picture. How are you going in with blinkers off to say, as you do the risk assessment, what are all the component parts that you're looking for that says, I need to put this as part of my risk assessment?
Okay. So when we are looking at any installation and building, we ask an awful lot of questions.
Which is a good thing.
Which is a good thing.
Yeah.
Sometimes they seem to come as a surprise to clients.
Yeah.
But we have a range of clients, some that are extremely risk averse and some that are, I won't say blasé, but are perhaps less concerned, which is absolutely fine. Ultimately, it comes down to what someone considers to be, valuable to them in terms of either preventing a fire, which obviously I imagine every owner of a building would like to do.
Yeah.
And also because lightning is a source of ignition, and also from preventing the damage that it can do to their operating systems and equipment. So when we look at risk assessment, we look at an awful lot of things, such as the location of a building, what it's made of, the likelihood of it being hit by lightning. So where is it, certainly in the UK, and the incidences of lightning in that area. We look at things such as, are people occupying the building? And if so, for how long.
Mm-hmm.
And obviously buildings like hotels or residential are far greater risk to people.
Yeah.
And obviously that greater risk is the ignition and fire,
Yeah.
which obviously nobody wants.
Mm-hmm.
And then we look at all of the systems within buildings,
Yeah.
and whether or not they're important to a client, and whether or not that client wishes to protect them, because it might not just be the equipment and the value of the equipment.
Yeah.
It could well be the operational cost
Mm-hmm.
as well,
Okay.
if it was knocked out.
Lovely. I think just one element before we move on to the next question. You mentioned obviously fire being one of those major hazards.
Yeah.
On the back of Grenfell and the Building Safety Act, how does that now flow into kind of lightning protection? And again, what questions are we starting to see from customers in those areas?
Okay. So obviously, the Building Safety Regulator, as part of the HSE, they operate as that independent regulator, even though they're part of the wider body.
Mm-hmm.
It was established as in response to the Grenfell Tower fire, and it's the enforcing authority for the Building Safety Act, 2022. And basically, they are now looking at the competency, not only just in our industry, but all construction, the competency of people to obviously do whatever role they do, and making sure that they're the right person with the right training, etc.
Yeah.
And Atlas is involved, our trade body is involved in that process with the Building Safety Regulator to ensure that people are competent to do. So there are quite a few plans about upskilling and improving all of the training that Atlas offers, and making our industry more robust, and giving people the confidence to do their jobs, and so that they feel competent in what they do.
Yeah, and that's really kind of important from a customer point of view as well, isn't it? That we're sending competent people to site,
Correct.
people that they interact with, and when we use that word competency, has a plethora of different meanings to different people about how you measure competency as well. So just give a bit of insight into what things you'd be looking for someone turning up to site. So if I was a customer or interact with somebody, what would you be looking for in the questions that they asked that they can really demonstrate their level of competency?
Okay, so obviously the document we work to, which is now known as BS EN IEC 62305, is quite a substantial document. I mentioned before, it's 4 volumes. And so for people who either design or inspect and test and maintain systems, it's extremely useful for them to have good working knowledge of that document. Otherwise, they wouldn't be able to do their designs or their inspections and know what to expect. And it means that people need to demonstrate that knowledge through training and obviously examination and measurement. And that's how they would demonstrate competency in understanding of the requirements by the documents that we use.
Okay, lovely. I think it's really important that we, as part of this and the discussion, is just trying to unbutton some of the areas in what people really need to think about. I think the answers that you gave there give a real good depth behind a multitude of different areas that people might just have that light bulb moment going, maybe that's something that I've overlooked. Just in the way of then the new standards, and you've mentioned there about the work that's being done across the committee. Why do these updates matter then? What's changed from the previous British standard to now the new standard? Can you just give some people a little bit of insight into what that looks like?
Okay, so many years ago we had, as I mentioned earlier, we had a document or documents that were pure British standards, and the one that's commonly known in the UK is BS 6651. There were documents prior to that, such as Code of Practice 326 and documents before that too, and they weren't revised on a very regular basis. There was something like 20 years between revisions, but knowledge has grown over the years, and now we're part of the international community when it comes to standards development. So 6651 as a document was replaced approximately 20 years ago by 62305.
Yeah.
We're now on the third edition of that. It is, as I mentioned, it's known as BS EN IEC 62305 to acknowledge the lineage of its international parent document.
Yeah.
So the biggest change between what we had as the second edition of 62305, which was just BS EN, and the document that we have now, which came out earlier this year, is that the risk management process has been comprehensively overhauled.
Yeah.
The concept of types of loss with public relevance have been added. The concept of a single risk, combining the loss of human life and loss due to fire, has been introduced.
Yeah.
And along with that, the concept of a frequency of damage that can impair the availability of internal systems and electrical equipment has also been introduced. This is a major change from what we had before, because the previous version of our document had 4 separate risk categories, and they corresponded to the different types of loss. But it was felt some years ago, and it's taken some development and to get all the national committees from across the world, if you like, to find agreement on the best way forward, that a more unified approach was preferred and appropriate, and bringing those separate risks together. And this is, hence the revision and the major change. But rest assured, all of the risk components that were considered before are still there in the background, and nothing has been forgotten. If anything, things have been improved and added to.
Yeah. So just listening to all those information, if we were to think about a checklist that people really need to think about then to conform with the new standard, what does that checklist look like for our listeners?
Well, I think the most important thing is to perhaps reconsider the lightning risk, and perhaps reconsider the lightning risk in terms of the latest lightning risk assessment process. It is still possible to use the previous version because that particular document is not being withdrawn by the BSI until 2027. And that is so that people can get used to using the newer version. But we are seeing more inquiries from clients wishing to use what is known as the 2024 version, albeit it was released in 2025. And the risk assessment process obviously has changed. It is thought that you'd like to think that the outcomes will be similar, but as the process has changed, there will be some minor differences.
Okay. And how might these changes affect then how people operate today? Will they see a massive change in adopting the new standards, or is it just based on the risk management process and the risk calculation that's been undertaken?
Well, I mean, officially, the third edition is a complete technical revision of that went before. And as you know, standards are not retrospective.
No.
So we can't suddenly force new thinking onto an older system necessarily. However, if obviously we've highlighted that there's additional risk or a different risk, then clearly it would be an owner of a building's responsibility to at least consider that risk. And so I would encourage people to get used to using the latest version of the document. And to reconsider the lightning risk, maybe look through the new process and understand how that might affect their building. And therefore maybe re-risk assess, or indeed if they've never had a risk assessment, I would encourage them to do so. That said, the risk assessment process is a method by which to attempt to quantify the amount of risk and the likely losses. It isn't an answer yes or no to will I be hit by lightning. And you could say that that's another misconception that we come across, is because I have heard it said, the result of the risk assessment says I will not be hit by lightning, or my building will not. And that's not actually true. The risk assessment process is simply a method by which to attempt to quantify the risk and the likelihood of something happening. Because if we risk assess a smaller building, such as a semi-detached house, for example, then the likelihood is that unless for some reason it was storing something highly flammable, then the risk assessment result would probably indicate that the risk of it being hit by lightning and there's being loss suffered would be extremely low. Having said that, you hear in the news that people's houses are struck by lightning, and their lofts, there's a fire in the loft, etc. So anything can be struck by lightning. The risk assessment process is merely a tool by which to attempt to quantify that risk.
So I guess on there then, the likelihood and the risk, if I think about a manufacturing plant, you might sit there and go, there might be a low likelihood based on where it's positioned in the country for where lightning strikes happen. But actually, if it did happen, the likelihood of it being struck, there could be a downturn then in regards to the production line not working, and that then could have a financial implication. Would that come into people's mindset when they start to work through that risk assessment?
Absolutely.
Okay.
The risk assessment process is a combination of lots and lots of factors. And yes, you're quite correct. You could have a large building in an area that's maybe doesn't suffer too much lightning activity or hasn't historically. However, it could be that the process that the building carries out is extremely important. So if a strike was to be suffered, the losses that could be associated with that could be massive. The loss of business operation and everything associated with that, the cost of replacing equipment if it failed, because of surges, etc. It could be astronomical. And therefore, all of those elements, like the fire risk and the occupancy by people and things, and whether someone has any hazardous areas defined in terms of what we call ATEX.
Yes. Could you just explain what ATEX is to people just who may not have come across that before?
Basically, it's the if you like, it's the way that we manage those European directives in the UK. And it's all about protection of personnel from the dangers associated with explosive atmospheres.
Right. Okay. Lovely. Great.
So if people, for example, one that springs to mind is something like a whiskey distillery. And sometimes they have large buildings full of whiskey barrels that are all maturing. Or rather, the whiskey is in the barrels. And if you ever walk into one, then there's certainly an aroma of whiskey, which is quite nice. But that can create an explosive atmosphere, and clearly lightning being a source of ignition, if it were to spark, which is obviously one of the things it can do, it could cause ignition and fire, and therefore you could have an explosion. The way that we prevent that happening is obviously by assessing the risk and then installing suitable systems to prevent lightning from becoming that source of ignition. Because the explosive atmosphere, you do not want lightning anywhere near it.
No. I know that you've worked in other areas like that before in regards to MOD sites where they've got ammunition, things along those lines. Just to give an example of a case study of where you've worked in where this has been really prevalent and how you worked and what solution did you deliver for the end client.
Okay. So, yes, we've worked for companies within the MOD. And certainly where they have storage of explosives, they have quite tight regulation, and they have documents that give very, very good guidance, in addition to what we would do under BS EN IEC 62305. They have specific requirements that are over and above, and we take those into account when we're designing systems. So we have, for example, where on situations where naval missiles, for example, were maintained or are maintained, they have buildings designed for that purpose. And on a regular basis, obviously, missiles are brought into that building, and the guidance systems are checked and things like that. I don't know the specifics because it's obviously
top secret.
We only are allowed to know what we need to know, and nothing else. But ultimately, what we try to do is we provide a lightning protection system as a whole system of protective measures that would prevent lightning energy from getting anywhere near the building in the first instance. And if it did get near the building, we also apply measures to negate the effects that it might cause. And we might do that by installing what we would call an isolated lightning protection system, which is basically one that is not attached to the building itself, but indeed is separated from by air with a decent distance between the two. And in the one I'm thinking of, the example, we installed a set of large metallic masts, and we put what we call catenary wires across between each a pair of masts
Yeah.
to create a protected volume underneath in which that building sat. So effectively that is designed to intercept the lightning strikes and take them away down the masts into the ground, and all of those masts are interconnected with an earthing system. And that would then direct the lightning energy and stop it getting into or anywhere near the building. Where cables cross that barrier from outside of that area into that building, we put a series of coordinated surge protection devices on all the electrical systems, whether it was low voltage power, fire alarm, PA voice alarm, measuring systems, anything at all really.
Yeah.
We put a series of coordinated devices, and when we say coordinated, we mean more than one device positioned at different points for the same electrical system that are designed to work as a team. They're designed to work together, and they have maybe slightly different jobs, but the idea is that they stop any form of sparking that might occur within the cables that lightning can cause, or indeed it will also rule out or remove the risk of any over voltages in the form of surges from causing internal equipment to fail, and clearly from causing any other sparking and obviously then causing something to ignite, and which you do not want where you have explosives or missiles.
Yes. So we've had a real juxtaposition there in regards to a whiskey distillery to ammunition, but it just kind of shows that there's varying different areas in regards to what would need lightning protection. It all comes back to the risk management and thinking about those standards and how then people are complying and thinking about that holistic view rather than the transactional view, isn't it?
Absolutely. I think the main thing is that unless you have something that's likely to explode, then perhaps people do not consider the risks that lightning can pose and the damage that it can cause. In a normal residential block, then people perhaps the biggest risk to them is fire, and you don't want that to happen. And so we don't want lightning to try jumping from one metallic part to another, which we call lightning flashover. Because when it flashes, it can spark between metallic items. And therefore, again, it's a source of ignition. And it has happened. Buildings have burnt down for that reason, because something has ignited and it's caused a fire. Thankfully, it tends to happen when buildings aren't occupied. Which is obviously a good thing, but still devastating for whoever owns the building. When it comes to buildings with explosive areas or explosive atmospheres, then clearly there's a risk of ignition needs to be avoided. But ultimately, the goal is the same: is to keep people safe and to keep the buildings operational and keep the buildings themselves safe.
Lovely. And that's been some great insight over this podcast. I think we've covered quite a few different areas there. So just for our listeners, just as we wrap up the session, Matt, what do you think are the golden nuggets and takeaways that people might want to think about when it comes to managing lightning protection? Because we've gone through an array of different things that could happen. Just the golden nuggets for them to think about, to reflect on.
Okay, so I think it's worthwhile considering the risks that lightning can pose and asking the question, is my building, are its systems safe? Are the people that occupy my building safe? In the event that they might need to evacuate, can they evacuate safely and in good time? And if I already have systems, are they fit for purpose? Are they suitably maintained? Do they look like they're about to fall off the building? And have I had them inspected recently? And is the whole system that I have, be it structural with the components on the outside, or be it internal, such as the surge protection devices, are they in good working order, and are they fit for purpose and suitable for the longevity that I expect them to do their job?
Lovely. I think that's a great number of nuggets there for people to think about. So I'd like to thank you for your time, Matt. I think it's been really insightful whenever we have the interaction. Any other kind of summary points that you'd like to just cover off before we pull the podcast to an end?
I think it's worth also saying that ultimately it can come down to cost against risk.
Okay.
So if the cost of a building or its replacement or its systems outweighs the cost of either installing or keeping a system maintained, then obviously it's a worthwhile thing to do. Installing lightning protection systems can help satisfy insurance companies. And it can obviously then give peace of mind to building owners and operators that their building is as safe as they could possibly make it.
Lovely. So I think, as mentioned, these interactions are always great, Matt, because I learn through these discussions. Hopefully people consuming the podcast have had those little nuggets that they can go away with and really think about how they're managing their lightning protection at their site or multiple locations across the UK. So I'd like to thank you for your time.
You're very welcome.
Thank you very much. All that would lead me to say now is if you can tune in to next month's podcast, we will have Tim Lee in, who's our compliance manager for height safety. In that session, we're going to be covering off the changes to BS 7883 2019 from a height safety perspective. And Tim will start to take us through some of the things that we need to think about to be compliant, how we manage that from end to end, and ultimately what are some of the pain points that customers are facing on a day-to-day basis in managing that new standard. So thank you for tuning in. We're greatly appreciated, and we'll see you in next month's podcast. Thank you for your time.